Hey everyone, and welcome. Today we're going to talk about something that sounds like it's straight out of science fiction. We're looking at a new AI method that doesn't just check for bugs in complex systems, it can actually mathematically prove that they are 100% safe. So, how on earth does that work? Let's get into it.
Just think for a second about the code that's running our world. We're talking about pacemakers, the flight systems in an airplane, or a self-driving car that's making decisions in milliseconds. For systems like these, one tiny bug isn't just an error message, it could be absolutely catastrophic. Failure just isn't an option.
So, how do you even begin to guarantee perfection? Well, you have to go way beyond just testing. You need something called formal verification. And look, this isn't about running a million different tests and just hoping you catch everything. No, this is about using pure, hardcore math to prove with absolute certainty that a system will always do exactly what you designed it to do and never do what it's not supposed to.
All right, here's our game plan. We'll kick things off with the massive challenge of proving these systems. Then, we'll look at the old-school methods and their limits. After that, we dive into the new AI approach, how it learns, the absolutely wild speed improvements it brings, and what this all means for the future of AI.
Okay, first up, let's really wrap our heads around the scale of this problem. Because we're not talking about simple apps here. We're talking about systems that have to run forever and can be in just a mind-boggling number of different states.
And this really is the fundamental question, right? For any modern computer chip, the number of possible states and ways it can behave is, well, it's astronomical. You could literally run tests for 1,000 years and you wouldn't even scratch the surface. It's just not possible. And that is the exact problem model checking is trying to solve.
Now, for decades, engineers have had some seriously clever tools to try and solve this. I mean, these are powerful methods, but as our hardware and software get more and more complex, these classic approaches are really starting to hit a wall. So here's the deal, and what this slide really shows is the tough spot everyone was in. On one side, you've got these BDD-based methods. They're mathematically perfect. They're what we call sound incomplete. But the problem is, you throw some complex, modern hardware at them, and they can just completely fall apart. They explode. Then on the other side, you've got bounded model checking. It scales much better, but, and it's a big but, it only checks a limited number of steps into the future. It can totally miss a bug that's lurking way down the line. So you're stuck, right? You have to choose between a perfect method that's fragile or a scalable one that's incomplete.
And this is where things get really interesting. A team of researchers basically said, what if we stopped trying to choose? What if we could build a totally new, unified way to do this, using AI?
To get this, you need to know about two big ideas. First up is safety. And it's exactly what it sounds like. Nothing bad ever happens. Simple, right? Imagine a train. The number one safety rule is that the train can never, ever derail. You prove this with something called an inductive invariant. It's basically a golden rule that, if it's true at the start, will stay true forever. It's the system's unbreakable promise.
But that's only half the story. The other side of the coin is liveness. This is the idea that something good eventually happens. Think about our train again. It's great that it never derails, but that's not enough, right? It also has to, arrive at the station eventually. You prove this with something called a ranking function. You can think of it like a progress bar that only ever goes down, proving the system is always making progress and can't get stuck forever.
And here it is. This is the big idea, the absolute game changer. The new method trains a single neural network to generate one neural certificate. And this one thing, this one elegant certificate, combines the proof of safety, the promise it won't derail, and the proof of liveness, the guarantee that it'll get to the station. It's a unified proof for the whole shebang.
Okay, so that sounds incredible. But how does the AI actually come up with this perfect proof? Well, it uses this really smart process called the learn, check, loop.
So picture it like a debate between two experts. First, the neural network, the learner, looks at the system and proposes a proof. It says, okay, here's my best guess. Then, a formal solver, the checker, comes in and tries with all its might to break that proof. It's a super strict fact checker. If it finds even one tiny flaw, what's called a counterexample, it doesn't just say, nope, you're wrong. It hands that specific mistake back to the AI. The AI then refines its approach based on that exact feedback. It learns from its mistake. And this loop just keeps going, back and forth, with the AI getting smarter and smarter until it finally produces a proof that is so perfect that checker can't find a single thing wrong with it. It's amazing.
So the theory is really elegant, but does it actually work? Is it fast? The answer is a massive yes.
I mean, the results are, well, they're kind of jaw-dropping.
The researchers themselves said it best in their paper. We're not talking about a little boost in performance here. We are talking orders of magnitude faster.
So just how much faster are we talking? Well, on almost half of all the tasks they tested, the new AI method was a full 100 times faster than the best tools out there today. That's already incredible, but just wait.
Because it gets way more dramatic. On more than a quarter of the tasks, it wasn't 100 times faster, it was 10,000 times faster.
And on 6% of the tasks, and get ready for this, it was 100,000 times faster. 100,000. To put that in perspective, a verification task that might have taken a traditional tool 24 hours to run, this new method could do it in less than a second. It's a total paradigm shift. And it's not just about raw speed. It's also about being more capable. Check out this chart. Within the 5-hour time limit they set for each problem, the new AI method actually solved 82% of them. That's better than the best traditional tool. So it's not just faster, it's actually more powerful and solves more problems.
So let's zoom out and put this all together. These results aren't just some cool academic exercise. They really point to a huge change in how we can build a future that relies on safe and trustworthy AI.
Look, if you remember 3 things from all this, make it these. First, this is the first AI-based method that can handle everything, both safety and liveness properties. It covers all the bases. Second, it's built on a brand new, more efficient neural network design. And third, it flat out beat the best tools in the world on a huge benchmark of real-world problems. It's the real deal.
And this really leaves us with a pretty profound question to think about. We just saw an AI learn how to mathematically prove that our most complex computer hardware is safe. If it can do that today, what else will we be able to prove is perfectly safe tomorrow? The possibilities are just getting started.